All right, let's talk about the two brains inside pretty much every piece of tech you own, the CPU and the GPU. They're the engines that make everything go, but, as we're about to see, they think in completely fundamentally different ways. So let's dive in.
So here's the big question we always hear. Who really runs the show? Is the CPU better? Is the GPU better? Well, the answer, as you can probably guess, is way more interesting than a simple yes or no. It's not about which one is better, it's about which one is built for the job at hand.
You know, the best way to get this is to imagine a restaurant kitchen. The CPU, that's your head chef, a total genius who can handle any complex, one-of-a-kind recipe you throw at them. They manage the entire kitchen, making critical decisions one step at a time. Now, the GPU, that's like an entire army of line cooks. They're not creating new recipes. No way. They're just perfectly executing one simple, repetitive task, like chopping onions, hundreds of times, all at the exact same moment.
So, yeah, they're both processors, right? Their mission is the same, to compute. But their fundamental design philosophies, the way they were built from the ground up, have gone in completely different directions to solve totally different kinds of problems. Let's unpack what that really means.
This right here, this is the heart of it. It's a tale of two philosophies. Think of the CPU as a latency specialist. Its whole existence is obsessed with one single thing, making a single task happen as fast as humanly possible. Minimum response time. You click, it happens. Now, the GPU, on the other hand, is a throughput engine. It could not care less how long any one task takes. Its only goal is to cram as many tasks as possible into a given amount of time. It's all about maximum work complete.
So how on earth do they achieve these totally opposite goals? Well, the answer is literally written right into the silicon. We're going to take a look under the hood to see how their physical designs are a direct reflection of these two warring philosophies. And wow, when you look at the specs side by side, the contrast is just stark. A CPU might have a handful of really powerful, blazing fast cores. A GPU, it has thousands of simpler, kind of slower cores. The CPU needs lightning-fast, low-latency memory access for quick decisions. The GPU needs a massive, super-wide highway of memory bandwidth to feed all those thousands of cores at once. It really is quality versus quantity, or speed versus scale.
Okay, now this is where it gets really fascinating. It's all about how they use their space, their silicon real estate. A CPU dedicates most of its area, we're talking like 70% of its transistors, to sophisticated control logic and big caches. This is all the machinery for making smart, split-second decisions. A GPU? It completely flips that on its head. It dedicates a whopping 80% of its silicon to just raw computation units, the ALUs. It sacrifices all that complex logic for just pure brute force mathematical power.
These different designs lead to totally different ways of working. The CPU is meticulous. It uses a sequential pipeline. It fetches one instruction, figures out what to do with it, executes it, and then stores the result. It's an absolute master of doing one complicated thing at a time, and it uses all sorts of clever tricks to make that single pipeline as fast as it possibly can.
The GPU plays a totally different game. It uses a model called SIMPT, single instruction, multiple threads. A single command, like color this pixel red, gets blasted out to thousands of threads all at once, and each one works on its own little piece of data. It's perfect for what engineers call embarrassingly parallel problems. Jobs so simple to split up it's almost embarrassing. But it has an Achilles heel, something called warp divergence. If different threads need to do different things, the whole parallel party grinds to a halt, and its efficiency just plummets.
Okay, so let's pull this out of the world of silicon and into the real world. How do all these deep technical differences actually affect the stuff we do every single day, from playing games to training AI? Well, as you're about to see, it all comes down to using the right tool for the right job.
In gaming, the CPU and GPU are in this perfect, beautiful partnership. The CPU is the game's director. It's running the show, managing the game's rules, the enemy AI, all the complex physics, and what happens when you press a button. The GPU is the artist. It takes all the director's instructions and actually paints the gorgeous picture you see on the screen. The frames, the textures, the realistic lighting, all of it. You absolutely need both to play.
Which brings us to the future. See, we're starting to hit the hard physical limits of how much faster we can make a single processor. The whole idea of Moore's law for single-core speed is kind of running out of steam. So the conversation is shifting. It's moving away from CPU versus GPU and toward CPU times GPU.
So that really leaves us with a final thought to chew on. In this new age of specialized heterogeneous computing, maybe the old question of CPU versus GPU isn't even the right question to be asking anymore.
Maybe the real question is, how do we build the best possible team of processors for the challenges of tomorrow? Thanks for tuning in.